Hi guys, we've got a special sponsorship deal for this episode of Deafen. It's from a company that is probably new to many of you, but they're called Paren Treats. Paren Treats is a brand new breakfast product that provides balance and fun. This year, Paren Treats comes in two new flavours, rainbow and unicorn. Both rainbow and unicorn flavours are completely vegan, so Paren Treats can help you lose weight on your carbon footprint. And that's why Paren Treats is proud to be sponsoring Deafen, the #1 vegetarian closure podcast. You can check out Paren Treats online. They have two websites because, of course, they also need to maintain a balance. So you can find them at parinfo.open and paredit.closed for more information. Now, as a Deafen listener, Paren Treats is offering a special deal. You can get 6 packs of Paren Treats completely free when you sign up for their free trial. Be sure to use the coupon code DEAFEN2018 when you check out Paren Treats. Thanks once again to Paren Treats for making Deafen possible.
Welcome to Deafen, episode number 30, and this is the first episode of this year, and I think around 12 people around the world already know that we are actually trying to live stream this episode, so we apologize for all the trying to set up the things, but the best part of this episode is that we have Mr Tellman on the show. Hello, Zach.
Hey.
So, welcome to the show.
Yeah, thanks for having me.
Thank you. And of course, we have Ray from Belgium.
Just about
at the beginning of the show. Yeah. I think he said he is having some technology issues, and so we're going to ignore him every now and then.
Yeah.
So, welcome to the show, Ray. How are you?
When the internet gets written in closure, we'll be all right. But for the moment, we're operating on a whole load of shit, so we have to live with it.
Yeah. So this is Vijay from Holland, and Ray from Belgium, and Zach from the US right now.
Yeah, Oakland, California.
Cool. Okay. So, there are lots of topics that we want to cover today. First of all, the book that you're writing, Zach. Where is the inspiration, and why are you writing a book?
Because I have terrible judgment. Yeah, I don't know. So, the backstory on this book is that, after my first full-time job writing closure, I immediately became an experienced closure engineer relative to the people I worked with. And so a big part of my job became training other people and trying to distill my sort of, half-formed judgment of like, what is good closure, what is bad closure, and explaining to people. And occasionally, if I told them, this is not a good approach, use this other one instead, they would ask me why. And I would struggle to answer. And so I wanted to try to kind of firm up my own understanding of it and kind of also maybe have a little bit more reach in terms of these explanations rather than just, whoever I happened to be working next to that day. And so that was probably about 5 years ago that I registered elementsofclosure.com. I was in St. Louis for Strange Loop. And I was at a bar with Chaz Emmerich and a few other people. And I said, there needs to be a Strunk and White for closure. And we raced each other to register elementsofclosure.com on our phone, and I won. And since then, I've been saying, oh, yeah, I'm going to write a book about closure one day. And I had a lot of false starts. And then eventually kind of the structure of the book became a little bit more obvious to me, like what I sort of felt it should be. And so I sat down and wrote the first chapter on names in like a week while I was on vacation about 2 years ago. And I put it up on LanePub, and the response was far better than I had sort of expected. And so I just kind of kept on going from there. And there have been people who paid me money 2 years ago who are still very patiently waiting for the book. Thank you, by the way.
Yeah, I'm one of them, Zach. So Come on.
That's
Thank
that's
you,
why
yeah.
that's why he's on the podcast, to ask you when are you going to finish the book.
And I mean, obviously that's a hell of a long time for a book to be sort of in progress, even though, during at least half that time I've like been working full time elsewhere. And I think the reason for that, in addition to me just being a very slow writer, is that the scope has broadened quite a bit from what I thought it was going to be, because it turns out that trying to give a reasonable sort of proxy for, my judgment requires articulating a lot of things that I didn't know how to articulate. And so there's just like a lot of reading and a lot of just kind of mulling over stuff in my head to be able to do more than, because like the Strunk and White thing, like that's sort of where the name came from. And it's becoming an increasingly inaccurate misnomer, I think, because now I kind of joke that I should just call it What is Software Anyway, the book, because like it gets much closer to sort of what is the underlying philosophy, right? I mean, names, like you can give sort of hard and fast judgment about, what sort of names to use in certain situations. But a lot of the time what you're trying to do is saying, you, the reader, have the domain knowledge that is required to make a good decision here. All I can do is provide you a framework to kind of plug your knowledge into and sort of weigh the various considerations. And that's a lot harder than writing a style guide. It's also, I think, much more useful than a style guide. I certainly hope so at this point. But so I've just been really struggling, I think, to write the book that I feel I would have want to have read maybe a couple of years into writing Clojure. And since I've been spending this much time, I kind of want that to count for something. And so I've been getting increasingly sort of ensconced on these increasingly kind of abstract questions about, naming and abstraction and like all these other sorts of things. And so, beginning in 2017, I actually quit my job so that I could spend some time working on the book and also working on a separate project. And the book just like I thought it was going to be 3 or 4 months of my full-time attention, and it hasn't been that. I've started reading books and finding that they didn't really quite answer my question, and so then I looked at their references and I read those books, and I've been just doing this breadth first search through the literature, and a year went by, and so again, I have terrible judgment, but it's getting very close to being done. So I'm about halfway through a draft of the final chapter. I'm giving a talk on it in New Orleans a month from now, a little bit less than a month from now. And so, I'm committed. I need to go and do this. The chapter probably won't be out before the talk, but I will write up the contents of the talk into the chapter soon thereafter. And then I look forward to stepping away from the book for a while. Like it's going to be a first draft. There's going to need to be revisions. Everything I've written in this book has undergone rewrites, but I think it's time for me to just kind of focus on something else for a little bit. So once I have a first draft to give to people, I'm going to feel comfortable, I think, not having any new updates for, half a year or something like that.
Maybe there's one question for you, Zach, actually, is, and like you say, you're a Clojure programmer and all this kind of stuff. But I've read half of the book and I'm skipping through the abstractions bit at the moment. I'm sorry to say, even I haven't got a year to spend reading it.
Well, I really that's hopefully not the thing. I really hope that it actually. I've read books where someone has tried to prove to you how much they've read. And I find those incredibly obnoxious. And so, my hope here is that, the book is hopefully not going to be over 100, 120 pages. And it's dense, but it's meant to be extremely concise and, hopefully is not totally unapplicable to what you're doing. And so if it feels like you've been reading for a year, I haven't done my job, right?
No. I'm quite the opposite. No, it's. I think I read the NIMS bit and then I saw the second bit and I just haven't got round to it. It's in the queue. But I guess my question for you, because I started reading the abstraction bit this afternoon. Actually yesterday afternoon. Okay, I'll tell you the truth. I was busy this afternoon with something else. So blah blah blah. My question really is why do you think? I've looked at the names and stuff. Why do you think this is specific to Clojure? Because it seems like a lot of this stuff is quite general, actually.
It is, and that's sort of why...
Why do you kind of glue it into Clojure? Or is it just a starting point for you?
Well, again, I mean, the book has grown in scope since I named it, and, let that be a lesson there, I guess. But
right.
the short answer is that, I don't know what an elements of software book would look like, because if there's not some sort of foundation there you could do what Knuth did for Art of Computer Programming and spend the first part of the book defining your own language, and then sort of, just kind of go from there. But I don't have 25 years to go and, do this. And I think that if I were trying to aim at a broader audience, there'd be fewer people who'd be willing to give it a shot. Like, I think the people in the Clojure community are uniquely willing to go and put up with my bullshit. But also, I don't know, the choices that are made in Clojure, even though many of them are choices which I've come to disagree with, having, spent 2 years looking at the language and the kind of decisions there. It's a well understood common ground between, me and the readers. And that means that I can, I don't have to spend a bunch of time explaining stuff and then exploring the consequences of what I've just explained. I can just kind of assume that people are coming in knowing what they know. And, maybe one day I will know how to write elements of software, but I don't now and don't plan to try anytime soon. So, I've been trying to, encourage people who don't know Clojure or know a little bit of Clojure, but don't, use it full time or don't plan on sort of getting very deep into it, and saying, read it and let me know how it turns out. See if this actually, helps you with software in general and not just with the Clojure language. But at the end of the day, it's the die is sort of cast here, right? Like I've made these choices. I'm aiming at Clojure. There's a lot of, all the examples are in Clojure, and if other people happen to read it and find it useful, I would be very happy with that outcome, but it's not the outcome that I'm sort of aiming for.
Well, yeah, I think it's okay. It's just a general question. So, but because I was thinking also that when I was reading it, looking back at it, I reread the names part as well, was that it seemed to be aimed at a certain maturity of project. It wasn't just a kind of like a 10-liner or a small library. It was about a kind of multi-year project or a big project, let's say, something which justified some effort to think about how you segregated your functions and your names and all these kind of things, rather than just something which you could throw together. Is that right, or?
Well, I guess saying, if you're using this now and you'll never use it again, do whatever, gets you to, from A to B, is a very short book and probably not a very helpful one, right? So, but also a lot of code that we write is throwaway, not because we want it to be throwaway, but because it's too hard to make it something that can, remain useful over time. I think that we're incredibly bad at doing that. And it's a hard problem. So I don't mean to, say that this is our fault for being, crappy programmers. I just think that we have gotten very good in a lot of cases at writing sort of throwaway code and sort of building stuff up from scratch, because it's too hard to go and reach back into, our Git history and pull out code that is actually something that we can use in this context, as opposed to just kind of taking the lessons we learned from that code and carrying that forward.
What do you think the difference is then? Because one of the things I thought about with functional programming was that maybe there would be more stuff that you could carry forward, a bit less kind of context required. But I know from the book you talk more about that everything sits inside of a context, which of course it does, but there's a sort of global context, and then there's a sort of narrowing of those contexts as you get down to your specific program.
Right. So this is something that I've been doing a small edit to the abstraction chapter, and one of the things I talk about. So one of the aesthetic of Clojure, right? The thing that we're sort of told is you have a bunch of these functions, they're sort of floating out there, and then you go and just kind of reach out and you pluck them and you put them next to each other and you compose them and then you let data flow through them, right? And so you and it's easy, right? And that's a really compelling idea, right? That we just have these like perfect functional like orbs floating up in the air and we can just go and kind of pluck them and use them however we want.
I have a suspicion you're going to drop these in a minute.
But I mean, I think that the only way that you get that sort of indirection, right? This sort of complete separation where like this orb is being used with this orb now, but can like, we can totally rearrange the whole system, is if no one cheats, no one kind of looks under the covers, no one goes and presumes that like, they're being used with this other thing over here. And I think that, cheating is the only thing that makes sense in some of these cases, right? Because a lot of functions we write will never be used with outside of the sort of context that they're in. And we should be able to rely on the details of how we're going through that. That sort of coupling is not inherently bad. That coupling is what makes it like possible for us to go and, build something. And, the example I give of this is the mitochondrion. So like this is the little organelle that sits inside, each cell. It goes and does cellular respiration. It's, the powerhouse of the cell. And it has all the markings of an independent organism, right? It has its own DNA. It has its own cell walls. But, 2 billion years ago, it got absorbed into, the eukaryotic cell and it hasn't left since. And so it can't exist outside of that context anymore, right? And it's been shaped to the needs of that context because it produces a lot more ATP than it itself needs. And if you were to go and like, cut it out and drop it in, some sort of other environment, it would die. And so even though we have these things that, are functional, right? They are referentially transparent. They have all this kind of these qualities that make us think that they should be able to, be used anywhere we want to use them. But in practice, I think that unless we have a lot of discipline in terms of how much we depend on the nature of the implementation, then that's not true, right? It's sort of false indirection. And I think that that's extremely true in Clojure as it is anywhere else, which is why, if you contrast how the Clojure ecosystem looks to say like the Node ecosystem, like we don't have one function libraries, right? We don't have a left pad library. We don't have these other sorts of things. And nor should we, I think, because if you have to go and kind of understand the API of a given function, like what shape of data does it expect, what kind of data does it return, that's a lot of work to just get one function's worth of utility, right? If you have a whole library, like the surface area of the API is relatively small to all the stuff underneath, and that actually makes it worth learning. And that means that within that library, people can go and make these things that are more coupled and are, only sort of purpose built for the purpose of the library, because people aren't going and reaching in and like pulling out one function and saying, oh, I just needed this, thanks, right? With that said, I think that in some libraries that I've written, I've taken pains to say that they have MIT licensing, because that allows you to go and just copy paste code as long as you put like a little inline attribution there. Because in some cases there are things that are generally useful. And in some cases you don't want to go and just create like your own little catch-all utility library that has a bunch of functions that you think might be useful to someone someday. But like at least they can if they ever want to. So that was a very long-winded answer to your question, but hopefully
I'm wondering, like you're using this analogy between, I don't know, biochemistry and then computing. Do you think that is going to be like easy to relate to, or is it from your background, or
certainly not my background?
Biochemistry?
Okay. So I think that I've had to cast a pretty wide net in terms of the reading that I've been doing, because there's basically one paper in the entirety of computer science that purports to say what abstraction is, and it's not a particularly great definition. And if you want to do that, there's a talk that I gave, which I kind of go into more detail. It's a paper called Proof of Correctness of Data Representations. And short answer is that like I could go and I could like come up with an example, right? So here I can come up with some sort of test application, and I could go and craft a whole bunch of examples where I say I'm going to define what the customer is and what the data model is and all this other sort of stuff, and then I can go and sort of play around with a bunch of examples. But I think that runs the risk of overfitting the examples to a very particular domain. And the nice thing about the physical world is that we all kind of understand it already.
Yeah.
And so I can draw analogies there which are imperfect because the physical world doesn't work exactly the way that software does, but it's close enough, I guess. Yeah. I mean, there are some people who have gone real hard on the whole, like, software should be more like biology thing. Anyone can go and watch Alan Kay's talks from the last 20 years because there's basically like a talk and a half's worth of material between them. And he talks about this a lot because he has a biochemistry background. And I'm not as convinced of the utility of that analogy as he is, but I do think that the mitochondrion example is a good one because it talks about how something which purports to be independent isn't, right? Yeah. And I think that's a very natural sort of thing. And so I think that you have to be careful about drawing analogies, but I think that there are very powerful analogies that require a lot less build up to kind of have the necessary impact. And that's sort of that's why I use that particular one.
So to look at other languages for a moment, especially functional languages, a lot of them talk about abstractions as part of the language. So you have abstract data types, you have higher kind of types, you have existential types and all these kind of things. And I noticed that you kind of you dodged a lot of that monadic type discussion. You don't want to get into that stuff, which is fine. I mean, who does? But they're claiming all of this abstraction in their type systems. Is that something that you did think about challenging, or because I know that Rich did it in one of his talks, and so
yeah, I mean, so I did think about whether or not I wanted to try to do this, and I realized that after kind of getting halfway through the chapter, I realized that what I was focusing on. So the paper I mentioned, Proof of Correctness of Data Representations, is like one of the earliest things about how do we prove that a data structure is correct, right? This was written back in like 1972. And there's been a whole lot of academic focus on this sort of question of how do we construct proofs, right? That's kind of the artifact that every paper needs to have for it to get published. Like even in cases where it's just talking about an interesting engineering result, people still need to have like some lemmas in there to get it past the reviewers. And that's fine. But that's sort of a cultural thing rather than something that like I think relates very much to what is actually useful in software. And the thing that I advocate in the book is that people should stop talking about software being correct. They should start talking about it being self-consistent, where self-consistent means, if we look at the implementation in terms of itself, like as sort of a self-enclosed little bubble, it does what it's supposed to do, right? But that's a completely separate thing than, is this abstraction, is this software useful given what it is that I'm trying to accomplish? And since that has to take into account the world, and the world is not reducible down to a finite number of elements that we can go and construct a proof around, all of these tools that we have, all these higher kind of types, all these other sorts of fun little toys that academia has given us don't help us, right? I mean, and I don't mean to go and say that writing self-consistent software is easy or a solved problem or like not something that type systems can really give us a lot of leverage on. I just don't think that it is actually the hardest problem. The hardest problem is dealing with the world and the environment that our software sits in and making sure that our software continues to adapt as the environment changes around it.
Isn't this something similar to, I remember reading an article by, I think probably one of the person who wrote IO or that one of those languages, that his idea, I'm sorry, I'm not really good with the names. I'll look it up later and then put a link to there. So that, I think it's similar to what you're explaining, that the types are only useful within the system, but at the surface area, you need to have dynamicity or dynamism to deal with the external world. Is it something similar that you're?
I think that's part of it, certainly. I mean, I think that this is orthogonal to the question of dynamic versus static types. I do think that having some dynamism at the edge of your system is helpful because the world doesn't have schemas, right? And so at the end of the day, we can go and we can have something that says, okay, you give me a bunch of bytes and I'm either going to say this fits exactly what I need it to be or no. and then tell them to like go away because they gave you malformed bytes. And that's okay, because if the computer is talking to another computer, they're both sort of rigid enough in that way that works most of the time.
What do you think about these companies like Yelp and all these other things, which are essentially trying to force a schema onto the world? Because they're trying to do that. I mean, they're all of these like Unix utilities that are, essentially becoming startups. They basically say, okay, well, the schema is location, rating, and that's it. And I guess, of course, maybe you're going to say the same as I'm thinking now, which is, well, they start like that, but actually they evolve into something much bigger, and the schema becomes very baggy and horrible. But that's where it starts for sure.
Well, I mean, I don't know that that's what I would say, actually. I mean, I should say that, sorry, I cut you off there. Was there anything else you wanted to say?
Nothing useful.
Okay.
We'll cut him off completely from the episode anyway. So
I did actually work for one of those companies that tried to have a schema for the world. It was called Factual.
Oh, yeah.
And it was actually an interesting one because in addition to having some well-formed data, it also tried to be sort of a foreign key for all these systems. So it had an ID that it would map onto a Yelp ID and onto a Foursquare ID and onto, I think, like 30 different sort of services, all of which try to capture facets, right? And I mean, Yelp is an interesting case, right? Because like the only things that we can measure, right? The only things that allow for us to kind of build these indices are things that are either enumerations or scalar values, right? And so Yelp goes and says, okay, you have a rating and I'm going to give you an average of the rating, or I'm going to do some sort of weird, kind of slightly sketchy elision of good and bad reviews based on like possibly them trying to scam the business owners into paying them protection money. But like, that whole thing aside, they also have all these reviews, right? Which are just bags of words.
Yeah.
And so someone could say, 3 stars because the service was slow, or 3 stars because whatever. And I mean, I live in the Bay Area where like apparently the fussiest people in the world live, because they'll go and give them like 2 stars because the decor wasn't quite up to what they would expect given the price scale or something like that. And so I mean, and it's ridiculous. And you can do sentiment analysis and other sorts of things. And if you look at Amazon's things, the reviews, they'll go and pull out common phrases and stuff like that. But at the end of the day, it's a much more amorphous kind of data that doesn't lend itself to this kind of quantification that computers kind of need to be able to deal with the data. And I think that's a recurring and sort of unsolvable problem, right? Because there is this amorphous data and we're trying to make it sort of very well defined so that we can actually do stuff with it.
Yeah.
The other kind of thing that I'll do, and this is a longer answer, and I should ask, just like, do we have some sort of time limit here? Because I've been like reading and thinking and writing about this like for a year, so I can talk.
We've got hours.
For a while.
We've got hours. I mean,
Perfect. Okay.
It's 8:00 now, 8:40. We can go for another hour and a half. I mean, I was actually thinking the other way around. That you might be heading out the door, but if you've got time, keep going.
No, not at all. It's fairly early here, so.
We got nothing else to do, so
okay.
We are happy to hear your thoughts.
So there's a book that I've referenced in a couple of talks, and that I think is a really great book called Seeing Like a State, which is the subtitle is I'm paraphrasing here, but like how projects to improve humanity have failed. And basically it gives a bunch of histories of cases where the government has looked at its citizenry and said, I don't really understand what the hell you guys are doing, so I can't really help you. So I'm going to go and create a model for how you guys live your life so I can start to kind of get traction on this. And the problem with this is that since the government, the sort of system that it creates is not optional, even if the model that it came up with is completely ridiculous, people don't get to opt out of it. And so they have to kind of conform to the model and so the government kind of destroys the structure that was already there without even realizing that it ever was there, because they're just like, oh, look at all these people living according to the rules I set up, right? And so the author, James Scott, he calls this the government trying to create legibility, right? To create a legible sort of environment so that it can go and kind of analyze it and respond to it and all this other sort of stuff. And for him, legibility is this thing which is this kind of pipe dream that, they should just go and like not try because they end up causing more harm than good. There's another book, which I don't know if this is what James Scott was sort of referring to, but it's a much earlier book called The Image of the City by Kevin Lynch. And in it, he interviews a bunch of people who have been living in some city for, a decade or more, and asks them to describe how do they get from one place to another place? Like, what are the sort of landmarks that they pass? Like, what sort of, their mental series of steps here without them actually doing it, right? They're just sitting in a room and narrating how they would get there. And using dozens of these sorts of interviews, he builds a little map of what are the common landmarks? What are the pieces of the city that sort of stand out for people that people sort of navigate and triangulate by? And, some cities like Boston have very well-defined landmarks, and some cities like LA or Jersey City are completely ridiculously like landmarkless, right? And so people say, I just turned left at like 111th Street. Like there's nothing there that kind of helps them navigate this. And so for Lynch, the idea of legibility is very important because it's what allows people to go and traverse a space, right? Something which is legible is a well-designed city. And it's interesting. And I've had a couple of conversations with people because one of the most common examples of a bad bit of city planning is this place called Brasilia, which was Brazil's sort of capital in 1965. They built from nothing. And it was this planned city, and they built these huge super blocks where everyone was supposed to live, and they built the government buildings in the middle, and they had these huge freeways connecting them. And like just from the get-go, when all the people, all the sort of the laborers that came out to build the city were done, there's nowhere for them to live because the plan hadn't anticipated they would want to stick around. And so they kind of lived out on the outskirts of the city where there's no utilities, no affordances for them at all, right? Because the city just had this kind of plan, and the plan was what it was going to be, and it's what the city still is, right? It hasn't really changed much. And so people didn't find it a very pleasant place to live because the city kind of imposed upon them its sense of how their lives should be. Around the same time, though, there's another city that was built according to the same kind of philosophy, which is Chandigarh in India. Yeah. And Chandigarh is interesting because I've talked to a lot of people in India. I was actually just in India last week for Enclosure. And they like Chandigarh. Chandigarh has it's sort of like central area. It's very well planned. There are rectilinear streets. There are, well defined street addresses. It's a very respected kind of bit of city planning.
Actually, I lived there for almost 1.5 years in Chandigarh.
Yeah, so I mean, it's something where I haven't heard anyone say a bad word about it, right?
Yeah, exactly. I mean, everybody loves this place because of the planning. That's what sets it apart from other cities in India, which are much more organic.
Right. That's the kind word. And. Yeah, I mean, but it's interesting because I've actually not been to Chandigarh, and I would love to go because I want to kind of see this for myself. But if I were to try to articulate what is the difference between these things, is that Chandigarh's boundaries are not set by the original plan, right? The city has grown around it. Yeah. And so what the original plan was is it was a seed, not an absolute set of boundaries that people sort of had to live their lives within. And I think that's a really important difference. Where structure is important, we impose structure with our software because that's what the computers need us to do to make these problems tractable, but it's also what we need to do to make them fit in our head, right? We have to impose some structure. We can't just say, whatever. Give us some data. We'll figure it out, right? Yeah. Like we even in dynamic systems, we do have expectations. We don't just say, give us some bytes, right? We expect it to actually be a particular data type with certain invariants, and will fail at runtime if those invariants don't hold true. And so I think that the real question is, do those invariants, are they at the root of the system, right? And does that mean that the entire thing has to be kind of thrown away if those invariants ever change? Or do we have invariants which kind of exist in parts of our system, and we have sort of more flexible glue that fits those different rigid pieces together so that we can go and we can replace pieces of our system, but we don't ever have to throw the entire thing away?
But do you think that closure hits the sweet spot between not having too much structure versus at least we have some structure? It's not going to be just bytes everywhere. compared to the very strict, rigid type systems that are going to tell you that okay, this is the invariant, covariant, whatever. At a very very detailed level description of what I mean by a type in Haskell or in other statically typed languages. So where do you think is Clojure is one of those languages, or do you think there are some other languages that you think are going to be much more in a sweeter spot like this?
It's a really interesting question. I don't know. I mean, I think that the space here and this sort of quote unquote sweet spot is not very well defined. I think that the major contribution in Clojure is immutability outside of a well-defined type system. That doesn't really exist anywhere else. And I think that it's an enormous step forward in terms of having dynamic languages. I will say though that a lot of the code that I write is actually pretty well defined, isn't changing very rapidly, and the fact that I can tell Clojure something's true, but it still discovers and rediscovers it at runtime over and over again is slightly maddening to me. And so I do end up going down into Java, because Java, while no one's favorite language, is a really good way of going and saying this is just what it is, right? And that allows you to kind of be much more rigid about this. And so the way that I've come to think about Clojure, and this is very informed by the sort of systems that I built with it, is that it is the flexible glue in between these other pieces. And the other pieces can be written in Clojure, but often they're like Java libraries, right?
Yeah.
They're just big old chunks of code that we kind of pull up. And what we're doing is we're writing the thing that connects these different pieces, or connects these pieces to the world. And I think it's exceptional at that. But the sort of purist idea that we need to go and write everything in Clojure, at all levels of the system, makes very little sense to me, because I think that it's good as a host language, or rather as a hosted language, and is able to sit atop these pre-existing chunks of complex functionality without having to go and actually do everything from scratch.
I have a question based on what you're talking about. I think a couple of minutes ago, that there are some things in Clojure that obviously you're explaining the Clojure's one of the strengths, that is being a hosted language. That's one of the interesting things that Clojure that the power of Clojure comes from. And you said there are some things that you don't agree with within Clojure. So can you give us some ideas about which ones, or which concepts that you don't think are not that useful, or why don't you agree with them?
I mean, I don't think that there are any large scale things. I mean, there are certainly parts of the language that I don't think are useful. But I'm very sympathetic to the fact that you can't just start ripping things out of Clojure because someone somewhere uses them, and you can't just go and say, oh well, it turns out that STM wasn't nearly as game changing as we thought it was. To the trash heap with it, right? As simplifying as that would be. So a lot of the choices that I kind of take issue with actually mostly circle around how nil is handled in the language. My favorite and most inexplicable thing is that the get method has a check at the sort of top of it, which says, is this an associative data structure? If not, get for the number 1 will always return nil. And the problem with nil in Clojure is that nil is a valid anything. And so it's going to go and cascade halfway across your code base before somebody does something that you can't do to nil, and then it throws an exception, and then you have to go and walk the entire thing back and figure out where did this nil come from, right? And the fact that get will return nil for anything means that let's say you have some sort of arrow expression where you're doing a chain of accessors, and you forget to actually put the data structure at the front. Then it'll do a lookup of a keyword on a keyword. And rather than saying, very reasonably, hey, that doesn't make any sense, it's just all right, no, whatever. And, we're kind of off to the races there. And I think that there's a lot of choices there that are weird. For instance, calling nth, nil is an empty data structure, but calling nth on nil will return nil. Even if you say, oh yeah, what's the millionth element of nil? And it's oh, it's nil. And it's that's not helpful, right?
But what do you think is the right behavior there then? I mean, should it be
Well, I mean, in the case
cop out
of,
and then throw an exception, or
well, no, I mean, I would think that nth. If we were going to say that nil is an empty collection, and it's a little bit flexible as to what that collection is. If you say, nth is an empty collection, then saying, what's the first element of an empty collection should throw an index out of bounds exception, right? It should.
Yeah.
And I mean, I think that there's this is kind of an interesting question, because I've been actually putting off writing the nil part of the book for a while, because I've been trying to figure out what is it I'm actually trying to say is like the right thing to do here. And in the idioms part of the book, I say, I'm trying to be very descriptive rather than prescriptive in terms of the practices. I'm saying, like, just here's what we do in the language. You might not like it, but doing it this way is going to make it easy for other people to understand. And the problem with the nil thing is that a lot of people will go and put this when x check at the top of their function, such that if it's nil, then I'll just return nil and short circuit. And I think that that's on reflection is a terrible idiom.
Yeah.
Because it just means that nil yields nil, and then you have to go and kind of figure out what's going on. And so I think that you have to be very clear as to what nil represents the absence of. And if you're able to say so nil is the absence of a map, right?
Yeah.
So you shouldn't allow that to nil to become the absence of some other data structure further down the line, because now it's completely ambiguous as to what this thing represents the absence of. And so that's something that I've been thinking about for a while. That's just an example, but I think that that's a something that is very easy to sort of Monday morning quarterback about, right? And I don't mean to go and say, oh man, that Rich Hickey, he really doesn't know how to design a language, does he? But it's still, I think, we don't talk about this very much, and for good reason, because it's kind of a distraction from getting stuff done. But I think that
this podcast is a distraction from getting stuff done, so it's okay.
All right. Well, then I'm in good company here, but it's
this is our way of not getting anything done. Sitting here.
But I mean, I think that there's a lot of these little sorts of things there.
Can I just talk about that nil thing a little bit more? One of the things that that some people say is if you use the reduce function or whatever, that there's some sort of identity function or some sort of canonical value for everything. So nil does not matter. It should never be anywhere, because you kind of always know something about what's missing. Or do you see what I mean? I mean, this is the argument that comes up. So how do you? I mean, we are what we are as far as nil is concerned. It's floating around there. But in theory, in principle, you should be able to say, okay, well, if you haven't given me something, well, I can give you something back, which is, zero or an empty list or whatever, some kind of canonical starting point.
I mean, I think that's true. Though, I mean, I don't know, it's something where, if I'm going and I'm saying, I want to, so take the update function. It is convenient for us to be able to call update on a map which doesn't have a key, and to take nil as an indication that the key wasn't there, right? And of course, it's a little bit overloaded, because maybe it also means that there actually was a value there and it just happens to be nil. But that's a useful compression of the code, as long as we're willing to just kind of agree that in this context, nil means this, right? And the problem is that there are a lot of different contexts where nil means a lot of different things. And if we could keep that all very straight in our head, then everything would be fine, but we can't. And so problems arise. And so I don't certainly, for instance, Git could require that you have a not found argument to it, right? And it just always requires you to tell you what this is. And so maybe you could say, oh, it's still nil, but you have to be explicit about that at least, right? But that makes your code a little bit more verbose. It makes it a little bit noisier, because you have all these sorts of values there. And I think that concision, rightfully or wrongfully, is a big part of what went into the sort of design ethos of Clojure. Just having fewer things in the sort of AST to specify a particular problem. And if that comes at the expense of some ambiguity, then that's a price worth paying. And I don't think that I can speak as to whether or not that's true. But I do think that that's very much part of the design ethos. And so you have to just kind of take it as it is.
And going back to the STM things, why do you think? Because I remember when Clojure 1.0 was released, and of course almost until 1.3 or something, this was one of the biggest topics in every book, and this was one of the things that you talk about. But obviously hindsight, that gives us better picture. So why do you think STM didn't get the level of or didn't live up to the reputation in terms of adoption?
So actually, do talk about this in the book. Spoiler
So
alert
go and
for
buy the book.
anyone who,
Obviously, VJ,
just buy it. Come on. I'm just going to start reading from my book. No,
For answer for this question, go and buy the book.
It's a little DLC for your podcast.
Yeah.
The short answer is that so atoms didn't exist in Clojure initially. I forget when they were added. I think it was before 1.0, but they weren't like initially part of it, and they were kind of just like an STM Lite. And it turns out the STM Lite is all we really need. And because the cost of using an atom is that you have less granularity in terms of the state containers, and also you have less throughput because you have to retry more often because there's sort of a little bit more contention on those pieces. But atoms are still fast enough because we're not doing huge amounts of logic inside these little update functions. And I talk about this a little bit in the book, where I analyze it as sort of a queuing theory problem, where I say, if we assume that, we have a millisecond update function for our thing, I think it was a microsecond update because it's like adding some stuff or whatever. It requires something like 600,000 updates per second before it actually starts to contend enough to give you 50% overhead, like half the time you're having to do a retry.
Yeah.
And we're not writing systems that have that much contention. And I think that the secondary thing, which, again, you can say in hindsight that this was predictable, is that if we did have that sort of system, we're not scaling at the level of a single big machine with a lot of threads. We're scaling with a bunch of different processes that are all talking to a database. And databases have well-defined transactional semantics, and that's where those transactional semantics have the most value. And so I think that's why it's not very useful, is that it's basically just a slightly faster and much more complicated version of atoms, and we just don't need to deal with that complexity. It doesn't really give us very much.
The other thing that's, again, maybe it's when we just to change gear a little bit in terms of the language, is there was a significant complexity brought around with reducers. I don't think you talk about that in the book, but maybe you should do in the next chapter.
I don't talk about reducers at all. For better or for worse, since I first conceived of this book back in 2012, there's been very little that's been added to the language, which I think has changed how people use Clojure. Spec has a chance of changing it. But going down the list, there's been core logic, core typed, there's been reducers, there's been transducers, there's been core async, which has changed some stuff, but I think that it's almost been exclusively on the front end. I don't think that people use it particularly much in backend systems, and where they do use it, it's not actually because they need to be using it. And so all these different pieces, they're fine, and I'm not. I think that the stability that we have is not something to kind of sniff at, but there just hasn't been this much stuff, and reducers, thankfully, just kind of exist in a little namespace. They've made the implementation of the underlying data structures more complicated. And, as someone who's written alternative data structures, they've made my life a little bit harder, but they don't really change very much. I think transducers have made things more complicated because now when people make an arity mistake, it yields this thing that's going to create this ridiculously opaque error. And I don't know. I'm sensitive to why that happened. In fact, as an author of an alternative, a stream library, having transducers saved me from having to go and write a variant of every single Clojure core sequence function. So yay, transducers. But I don't think that it's changed how people approach the language. And in as much as I'm trying to, again, be more descriptive than prescriptive, I feel pretty comfortable just ignoring that.
The reason I mention, actually, I meant to say transducers, not reducers, because I feel like one of the things, if we think about what is like interesting about functional programming, is laziness, and transducers flip that. So, don't you think that's a big change? That actually, all of the kind of the way that you process data suddenly has to be eager. You have to think about that.
Well, that's a really interesting question. For a couple of reasons. One of which is that I talked to Rich about this, and he said, so I mean, I don't think he's gone on the record, but he said if he had thought of transducers earlier, he would have made laziness much less of a default option in the language.
Right.
Because you need to have some sort of way to compose stuff where you're not doing like n many passes over the collection each time that you want to like do a series of operations. That doesn't work. That's a non-starter. And so laziness is an obvious way to do that, but it brings a lot of stuff along with it. And this is actually something that I'm talking about in the chapter I'm currently writing, which is on composition. And one of the things I kind of talk about is I say that, there's this thing that I'm calling a process, which is a sequential set of operations where you're either pulling data in from outside the process, transforming the data that's within the process, or pushing data outside the process. And so this could be a thread. Typically it's a thread. This could be like one of the old Unix processes. This could also be like a chain of callbacks. This could be like a core async Go routine. There are a lot of things that sort of have these properties, but like for the purpose of just thinking about a thread, in the most common case, you want to be pretty clear about what the different steps are in your code. You want to be able to say, okay, this code is pulling stuff in, right? Because this is reliance on some other thing which is outside of my process, as opposed to this is something which is going and just transforming data that I already have. And lazy sequences conflate those quite a lot, because when I give you a lazy sequence, it might be a fully realized in-memory data structure that I just mapped over, and so now it's a lazy view into that. Or it might be something which is actually like reading from a file or reading from the network or something like that. And I think that actually is something which, again, this is one of the few cases where I'm advocating for a different style of programming than people typically do in Clojure, which is to say that you want to have something be, you want to distinguish very clearly between things which are operations that are reading from somewhere else and operations which are just transforming data that you already have. And the interesting thing about transducers in that context is, like, there are a couple things that you can't do with transducers. You can't do sort, because sort requires you to go and like hold the entire thing in memory. And I think that, like, if you kind of consider this in the case of lazy sequence, we can call sort on a lazy sequence. And what that does is it goes and realizes the entire thing and then copies it into an array and then calls like Java's array.sort on it. And that's okay if you already have the data in memory, because presumably if you can fit one, you can fit two of them. But if it's an infinite sequence, calling sort on it is, going to cause a lot of issues. And that's one of those sorts of cases where it gets kind of complicated. And I think it's worth looking at how the GNU sort thing works, because what it does is it goes and pulls in pieces, like chunks of the data, and then it sorts those in place, and then it spills it to disk. And then it keeps on doing that until it's exhausted all the incoming stuff. And then it does like a little merge sort of all the chunks that it spilled over to disk. And of course, if it isn't too big, then it will never do that. It'll just keep it in memory. But this is something that is able to deal with much larger file sizes than it might otherwise have to. And in part, that's an artifact of the fact that it was like written for the PDP-11 or whatever. But it's, this is a very clear separation between the act of reading in and then the act of sorting, right? So there's something which is going and pulling in only a bit of data and then calling sort on that and then pushing that out. And that's a much more sort of regimented approach to this. And in some cases we can say, okay, well, I know exactly what the data is that I'm sorting. It's just like a little config file or something like that. I can go and I can, read it from disk lazily and sort it. No big deal. But that means that we can't, like, this gets back to the whole question of reusability, right? Now we have this sort of assumption baked into our code that, this works on any lazy sequence except the ones that are too big. Please don't do that. And that's kind of a very fragile thing. And I think that being more deliberate about that and thinking more carefully about, when we're dealing with realized versus unrealized data would be a helpful bit of discipline to have.
Yeah. So I was just wondering so you built this. No, we would like to talk about the project that you're working on from your sabbatical. So, can you give us some idea about what you're working on and what is it about?
Yeah, keep in mind that I haven't really perfected the elevator pitch for this, so
It's
more
okay.
of
We have 1.5 hours.
yeah,
so.
it's think of it as a very long escalator pitch.
Yeah.
So
I hate escalator pitches, mate. I mean, we had an escalator guy recently. You know, I don't think that's working out. It's not a good model. You know.
maybe one of those really long like airport, like the
Yeah,
little moving sidewalk things.
Yeah,
It's just
yeah.
like
Let's go
just a
with
very long terminal. So basically, I wanna write a tool for what I kind of am tempted to call exploratory data processing. And there are tools we use for this sort of thing where it's like it's not that we know how we want to get between A and B, it's that we're looking for a path between these things, right? And a lot of like the tools we use to write code presume that we kind of know where we're going and how we want to get there.
Yeah.
But I think that most of the time that we're writing code, that's not true. And in fact, we would benefit from having tools that are more focused on that exploratory phase. And we do have some tools that sort of fit this, right? We have the shell. The shell has these sorts of things we can pipe together. We have the REPL. The REPL is an excellent tool for trying to figure out, like, how do we get data from, this shape to the other. And then we have stuff like Python notebooks, which are for data analysis, which is a sort of subset of data processing where the end result is meant to be something that is consumable by people. Like we can kind of, it's either a small set of numbers or some sort of picture or something that we're good at understanding. And the problem with all of these things is that the exploration process is captured as this sort of linear set of things that we typed into the computer, right? That's what happens when you type history at the bash prompt. It's like, here's all the things you typed. The problem is that the exploration process is not linear, it's branchy, right? We're trying a bunch of stuff and we're backtracking, we're trying a different thing. And that narrative, that sort of structure of that branchiness is in our head, like, for up to an hour after we did it. But like after that, it's gone, which is why, like, I know people who have the last 5 years of their bash history, like sitting in a file somewhere, but it's like kind of useless to them.
You don't know which one. Yeah,
exactly. Or like,
Yeah.
how do these things relate to each other? Like, oh, was this like thing where I write to this file? Was that necessary for this other thing to work? I don't know.
This one, yeah.
And like, if you have this sort of discipline of making all of your bash things one-liners, where you're just going and like building up this ever longer sort of concatenation, then that kind of works. But like, that's also not great, right? And so the having sort of said all that, kind of what I want is Git for REPLs. I want something that kind of captures the branchiness of this exploration, such that if you try 100 things and the right answer ends up being 4 things, you shouldn't have a big list of 100 things. You should have 4 things in front of you and then everything else off to the side. Right? There should be this sort of DAGgy topology to this that you can go and you can kind of, concatenate, like compose onto. You should be able to go and sort of pull stuff in, and you should be able to, most importantly, search through it, such that, now this is actually, I think, a much more useful kind of representation of the history of your exploration. And even like, a year, 5 years later, you can go and look at it and kind of get a sense of what it was you were doing. Right. And I think that this gets to something that I was sort of alluding to earlier, which is we don't build stuff to be reused very often. We just build stuff like that is sort of one-off throwaway stuff. Because if you go and write this little crappy script that, parses a log file and gives you some statistics about it, going and parameterizing that and writing like documentation and all this other sort of stuff, it takes at least as much time as writing the script did. And, we almost always, I think, or at least I almost always opt for just throwing it away and writing it again 6 months later when I need it.
Yeah.
And so the net effect of that is that, having been a professional programmer for a decade, I have a decade's worth of experience at writing stuff from scratch, not a decade's worth of tools in my toolbox. And that seems like a not optimal set of, circumstances here, right? I should be able to go and, copyright attribution allowing, be able to reuse stuff and, take stuff that was part of an overall set of operations I was doing and be able to sort of pull this up, right? And so a really important aspect of that is saying, each of these steps needs to be like a functional transform data, because if we have that, then we can take any subset of that and just kind of lift it up and say, this is a function now, this is reusable, right? And you, I think, need to have some sort of type system there, so it's a little bit more explicit about what shape of data it needs. It needs to be a lot more concrete than, what the bash environment gives you, which is like, it's text, and but like there's stuff to learn there. And I'm kind of waving my hands very wildly here because the original plan was to work on the book for 3 to 4 months and then spend the remainder of 2017 building a prototype. And it turns out that 2017 was all about the book. And so now 2018 is all about writing the prototype. And so what I hope to have by the middle of the year is like some very rough kind of screencasts I can do that are sort of like proofs of concepts and everything like that. And by year's end, have something which resembles what I'm describing here, such that I could, I don't know, do a Kickstarter or something and sell it as like a developer tool.
Okay.
And so a few people have asked like why I'm doing like open source stuff where I'm writing a whole bunch of immutable data structures under a GitHub organization called Lacuna. There's also something there that does a bunch of like geometric primitives and stuff like that. That's all little like scaffolding that I'm building up or foundational stuff for this tool.
Okay.
Because you need to have something which is a series of sort of pure transforms over data. You need to have good immutable data structures. And because it needs to be have like sort of geometric primitives, you need to have that. And I'm writing the entire thing in OpenGL because that's just me kind of because I like OpenGL. And
is it something similar to? I recently saw a link about software called Luna or something.
It's so there's just not
is there
dissimilar.
Any conceptual? Yeah.
I mean, so what Luna says is it turns out that basically you can treat any pure data structure or any pure sort of set of computations as like this sort of DAG data flow, right? Yeah. So like you have the tree, which is like the sort of normal expressions. And then if you have a let binding, then you can go and you define it and then it kind of gets as an inward edge sort of elsewhere. And so you have a DAG. And what they have is they say, okay, you can write code or you can build out the DAG, and then like there's sort of this isomorphism between the two, such that what changes in one affect the other. Yeah. This is sort of speaking more to sort of a bit of fussiness that I have, but one of the things that all these tools have, and this is something that I've been struggling with a lot in terms of finding prior art that I feel like I can build upon. There's a whole class of tools that do like visual effects or sound effects. There's something called Max MSP. There are other sorts of things that allow you to go and say, I have a node. This node represents a transform over like graphics or sound, and I'm going to drag wires in between them because I feel like that allows people who do not think of themselves as programmers to not be scared of the programming that they're doing. The problem with this approach where people are like literally dragging wires in between stuff and rearranging nodes using their mouse is that it turns into a mess. And people spend a lot of time going and trying to like group stuff and everything like that. And it's awful, right? It's an awful way to go and do this. And so the way that I've described this as like what I'm looking for, and I don't know precisely what this looks like yet, is I want peredit for DAG editing, right? Okay. Because what peredit gives you is this structural editing where you're not fussing with like the individual parentheses or trying to kind of like, get everything just so. What you're saying is, this is now connected to this, or this is now outside of this, or anything. And these are just simple mechanical transformations where, it doesn't require you to go and be fussy about where everything is laid out with respect to each other. And the Luna thing I was very excited about, but then you see when you watch the video, that, someone goes and takes a node and they kind of drag it out. And I'm like, but why, right? Like, who's asking for this, right? Yeah. And I think that's fine, and that's probably that is not a substantive critique of the Luna thing, but they're also kind of going in a bunch of different directions, and they want to go and kind of make it as a general purpose programming environment, which is not what I want. I want mine to be sort of more exploratory.
That seems a bit more like a stretch goal, right? I mean, making these kind of tools very generic enough is that makes them, I don't know. I mean, for a given scope, they look really nice. For example, if you're building like a domain-specific languages like VHDL or VLSI programming sort of stuff, they have these primitives that you can use, and they have these even the CAD tools that you use. They have very specific set of goals. The very moment you stretch the scope, then these things become, I don't know, super messy. I mean,
well, that's the thing, is that like, so, this is also something that like I've kind of am alluding to in the book, which is like, I'm trying to come up with these diagrams where I talk about, we have interfaces and we have these things. But like, if you've ever like used a data, like a code dependency visualization tool, like they come up with this like weird, like bird's nest of like, lines between things, and it makes nothing clear. Right. Yeah. And I think that for certain things that you're doing where there is this kind of very clear linear chain of like, I'm trying to get from here to here, I'm trying to turn data from this shape into this shape, and you're not doing this like complex orchestration, you're not trying to write general purpose software, you're not trying to write like a UI or something like that has like a lot of these sorts of things that are tied together or all kind of fan in and fan out from a central point of control, then I think that works. But I think that the moment that you say this is superior to text, or like at least a good sibling to text as a general purpose way to understand our code, I don't believe it. And that's not to say that like these tools can't be useful, but I think that, a lot of them are claiming to do a lot more than they can reasonably expect to. And I think a lot of that, I don't know what the Luna tool is, like what its funding is, or like whether it's an academic sort of project or commercial or whatever. But a lot of the other tools that I've looked at have been commercial, have been venture funded. And the problem with venture funding is that like, if you're going to go and try to solve one problem, you're going to try to solve them all, because that's what you need to tell them. You're just like, you need to find a path to being $1 billion business.
And then put blockchain in it.
Oh, right. Or something, right? Just come up with whatever the sort of buzzword du jour is.
Yeah.
And I think that a fairly unfortunate casualty of this was Lighttable. Lighttable, I think, was a really good medium-sized idea, right? It had some good incremental improvements to how to do text editing, how to do development. But they took like $1 million in funding from Andreessen Horowitz, and like that was it, right? Because you can't go to Andreessen Horowitz and say, we have a moderately better text editor. So now like, oh, well, we're making a better spreadsheet. Right. And like, I don't know if they're going to succeed, like fingers crossed. Like they're all, very smart and dedicated people, but like that's a go big or go home kind of outcome. And I think that like, frankly, the state of development tools is poorer for the venture capital kind of ecosystem that surrounds it, because there are very few things that we can do with software that will be these sorts of home run wins, where it just kind of transforms how everybody does software. Like the way that you go and you create better tools is by identifying a narrow scope of a problem you're trying to solve and building a tool which is purpose built to that problem.
Do you I mean, I guess you have watched the Brett Victor stuff. Why wouldn't you have? So I have this theory that he goes back to Doug Engelbert all the time, and to Alan Kay and all these kind of guys. And he's done some stuff with his feedback loop between the visual and the text, and he's done some stuff about stop drawing dead fishes, and there's a lot of these nice things. And now he's with this dynamic land, but I don't know why, but I have this suspicion, and maybe you can say I'm wrong, but I think he's just catfishing the whole industry. Yeah.
Well, I think he's actually been pretty upfront about this. I think a lot of people have like watched one or two of his talks and then been like, oh, he has like a new idiom for programming, right?
Yeah.
And like, that's not what he's saying. What he's saying is, here is a type of interaction that I think that we should be aspiring to. And the thing that was interesting about Lighttable, which, frankly, it didn't achieve, right? But what it was something that was saying, that thing that Brett Victor hypothesized should exist, we did it.
Yeah.
And so I think that was very exciting, like legitimately exciting. I paid money for the Kickstarter because I wanted to see what was going to happen there. And the fact that it didn't quite achieve it is fine. Like that wasn't like a disappointment to me. But I think that like when Brett Victor says like, it's not that he's coming up with something which is like a better way to design circuits or a better way to animate fish or like what have you. Like he's just saying, here is a type of interaction that we should be aspiring to.
It worries me a little bit though that the reason why I call it catfishing is because of this discussion we've had, which is, yeah, that's a nice aspiration, but are we ever going to have a tool like that? Or maybe we'll have 100 tools like that, that do something for circuits or do something for particular types of drawings. Is that what we're trying to get around to, do you think?
I mean, I don't know. So a friend of mine recently shared a quote with me, which I liked, which I think was Oscar Wilde. And I'm paraphrasing here, but he says, any map which doesn't contain utopia is not a worthwhile map.
Right, yeah.
Right, because that's what like gives us something to kind of aspire to. And progress comes from reaching for that sort of utopia. And so people like Brett Victor are important. I think he's clearly a brilliant guy. I think that he's doing a good service by making people imagine a better future. I think that the fact that people sometimes think that he's the messenger of a better future as opposed to just kind of like sketching it out is not his fault. It's theirs. But like that is something where I don't know. I mean, I don't mind that. I don't mind going and waving your hands. I think I do mind the fact that the only people who get funding are people who are trying to realize that utopia, as opposed to people who are trying to incrementally sort of move in the direction of it, right? Yeah. Like the whole like kind of I'm going to go and sail out into the ocean and like either I'm going to come back rich or dead is like not that's not a sustainable mode of it's not a sustainable anything really. Like I think it's very harmful to like every aspect of professional programming.
But isn't it just feeding greed over progress?
Well, I don't know. I mean, so I've lived in the Bay Area more or less my entire life, right? And I know people who like work in venture capital. Like this is something where like it's something that's there, and I think that there is a there. Right. And you can reasonably point to a lot of examples of where people swung for the fences and, actually accomplished that. Yeah. And, you can call it survivorship bias, and it is. But that also means that there is a possibility these things can exist. And I think that, one of the...
What example would you give of that, actually? Because I'm a bit skeptical of it.
Okay. I mean, you can go and you can just look at, they go back to why they call it Silicon Valley, right? You have like Fairchild and all the kind of
the semiconductor stuff,
like semiconductors.
Yeah, absolutely.
Yeah.
But
and so like and there's been other sorts of examples. What?
eBay.
And I think that there are other. So I'm reaching back to the past for a reason, right? A lot of the stuff that's going on right now is just people doing sort of arbitrage on this. I do not think that Uber represents like meaningful innovation in this sort of thing. Yeah. I do not like. There's a lot of stones that you can throw at this, right? And but I mean, I think that if you were to go and articulate one of the few like really great aspects of the kind of American culture around business, it's that failure is allowed and encouraged in some cases, right? Bankruptcy laws, these other sorts of things are extremely lenient in that sort of respect. And it means that people can go and swing for the fences. And if they fail, like, poor them, they go work at, Google or something like that. It's not like there is an ecosystem that allows people to go and kind of dream big. And, it's a shame when those big dreams are, Uber for, pet shampoo or something like that. But like and I don't want to seem like I'm parroting kind of the Peter Thiel talking points of like, where are our jetpacks? Because he's like a, vampire who is like, in many ways, a reprehensible person. Yeah. But, there's truth there, right? I mean, people wouldn't be saying that if there wasn't some sort of truth there, and people wouldn't be continuing to invest there if there weren't some value. I think the problem is that the noise has just overwhelmed the signal to a great degree, like in the present.
I think we're getting way off topic now, though.
Yeah, that's true. I think we riffed on the entire Silicon Valley.
Can I just make a start? I mean, we at the beginning of this episode, I was going to say something to you actually, because the episode before this was with Zach Oakes, and now we have Zach Tellerman. So I was asking VJ actually whether or not we're now not allowed to have anyone on a podcast that isn't called Zach. Because
or they're gonna change their names.
Yeah, I think that.
Well, I mean, you should be aware that like it was a very popular name right around when I was born. So just make sure that you target a bunch of American dudes who are in their early 30s, and like you'll be golden. Just
I think the gender balance is going to suffer.
But what is the female version of Zach? I mean, is there a female?
I don't think there is one. It's a biblical name, and not all of those have like male and female equivalents.
Oh, okay. I'm not aware of this.
Isn't it Zill?
with Z.
Zach and Zill went up the hill. Sorry. Yeah. Okay.
Anyway, so I think we can get back to a bit of closure before we. Wow, it's 1 hour 15 minutes. Okay. So how did you get into closure? Of course, I mean we talked about post-closure era. Can you give us like pre-closure era, and what were your frustrations that you that pushed you into closure?
Sure. Yeah. So I went to school for computer science, and for 3 of the 4 years that I was at school, I was pretty sure I wanted to work in video games. And after having actually looked at what that was, I realized that was actually not a thing that I wanted to do.
Yeah.
But I was coming out of school with a focus in graphics and computational geometry, and it's something that I still to this day really enjoy, just as sort of a thing. It's a very satisfying thing to make computers show you images that are very kind of visually stimulating. And the problem, though, is that if I didn't want to work in video games, a number of things that like did graphics were pretty limited, and I ended up at a company that did video surveillance software that was doing like trying to do video analysis, and they were coming up with custom UIs to kind of do video playback and show search results and stuff like that. And so they were a C# shop. They were doing actually a desktop application, and so I got deeper and deeper on like the low-level Windows graphics routines and stuff like that. And after a number of years of that, I kind of looked up and realized I was going in a direction I didn't want to be going in. And so I started looking for a new language. And what I did was for each new language, I tried to go and write a little OpenGL wrapper in it, which is a terrible way. Kids don't grow up to be me. Like this is a terrible criteria to go and like choose a language on. But I tried Ruby. I tried OCaml. I actually played around with Erlang a little bit, but they didn't have OpenGL binding, so I kind of tossed that aside. And but then a director of engineering at the company I was at was Tom Fallhaber, who did Clojure, PrettyPrint, and a few other things. And this was like way back around the time of 1.0, like maybe a little bit before. And he was very excited by Clojure because he was a old Common Lisp head, and he was talking about it a bunch. And so I thought I'd give it a try. And according to like my very rigorous metric of how quickly can I start getting 3D graphics on the screen, Clojure was far and away the best, because I just had to go and take the existing Java bindings and just kind of like poke at them. And so that was the first thing that I did with Clojure. Was my first ever open source library was called Penumbra, which was an OpenGL wrapper for Clojure, which, as far as I know, I was the only ever active user of, because it was not a very good API. It was extremely like customized to what was sort of fun for me at the time, right? And like tons of macros, all this other sort of stuff, because OpenGL is an extremely verbose API, and there's a lot of sort of wasted stuff, and like, I can just like write a macro here and write a macro here, and pretty soon it's like something that only makes sense to me. I even had something that would take Clojure and translate it into like GLSL shader code.
Wow.
Yeah, and like of course like it did basic type inference and other stuff, but it had a bunch of holes that only I knew, like what sort of code you could and couldn't write. And so like it's on GitHub, and I just like had kind of like let it fall aside, and people were like, hey, should I use this? And I'm like, no, you really should not, because like it's like but that was sort of what got me started. And I think that it's a slightly atypical use of Clojure, because it's an extremely imperative API that I was building on top of. Is an extremely imperative use case in general, but it allowed me to kind of play around with this stuff, and I was much more productive in Clojure to do kind of little toy like graphical demos than I was in C++. And I just kind of went from there. So I ended up leaving that job and going to Google shortly thereafter, and Google, of course, did not have Clojure. But I was only there for a short period of time before a local startup that was doing Clojure asked me if I wanted to join, and I kind of hemmed and hawed for a few months, and then I left. And I was working full-time in Clojure, and have been with a very few exceptions ever since. So that's been kind of my story, and I've been fortunate in that most of the companies I've worked for have been very happy to have me kind of do some open source work during my day job. which accounts for sort of the sheer number of libraries I've managed to crank out over the years. I don't know. That's sort of that at a very high level.
I remember that. Didn't you do a talk about the macros that you learned from the composition of the macros was a problem after Penumbra?
Yeah. I've actually done a couple of versions of that. So I give a very in-depth example of like a graphics for Clojure and a talk called Distilling Java Libraries, which was a ways back, and then sort of reprised that material in one that was called Always Be Composing.
That's one I've seen.
But that was good. Yeah, that's a favorite example of mine, because I think that as long as you're just kind of talking about, oh, we're going to transform this data into the other data, like unless you go and push that data somewhere, do something with it, like all you're doing is kind of raising the ambient temperature of the room. And so I think that that's actually a really, I mean, it's interesting, right? So like we were talking about Haskell and sort of strict type systems, and I think it's telling that Haskell is really good at writing compilers. And that's because that's a very, basically it doesn't have side effects per se, or like if it does, it's really much at the edges. It's just turning one shape of data into another shape of data. It's also an extremely well-defined problem because you get to say what the inputs and the outputs are. And, if anyone wants to write something that doesn't fit it, you just go and kind of, give them the finger and like give them some sort of, parser error or whatever. So it's, that's a really good fit for the kind of very prescriptive kind of approach to that thing, and also to the the strengths of functional data or functional programming, which is data shape to another data shape. But I think that when you really want to start judging, like, is this a good approach overall, you have to talk about, like, okay, well, now that we have our data, what do we do with it, right? And sometimes it's literally just sending it over a queue. Sometimes it's like printing it out to the screen. But for the most part, in real production stuff, we're doing something non-trivial with it, and I think that you can't really safely ignore that. And that's also been a focus of a lot of the libraries that I've worked on. Certainly the most popular ones have been like Aleph and Manifold and other stuff, which are like very much about side effects, right? And how do you deal with that? And I think that that's an important question for anyone to go and look at. You can't just go and say, oh, we don't talk about that, right?
Can I just interrupt you by quickly saying thank you for Aleph, by the way. I think so many people are using that, and we so many people we talk about programming, and Aleph is one of those things which I think, I don't know what the stars are on GitHub are or whatever, but I know that in the Clojure community that you're very treasured for that library, because it is superb. Thank you very much.
Well, I'm glad. I mean, I think that, like, again, it's one of those things where it came out just as like Node.js was coming into ascendancy, and I think a lot of people are like, oh, event-driven stuff. I know I should like that. And so I sometimes question how many people use Aleph because it's the best solution for their problem. How many of them use it because it seems cool? And like, it's fine for me either way, I guess. But it's something where it was very it took advantage of sort of the hype cycle, and I think that accounts for at least some of its popularity.
Yeah.
No, that's just you being modest, I think. Okay, so we just have one before. I think we are almost 1.5 hours, but we'd like to know, your thoughts about spec as a conclusive question for this episode. Obviously, you need to come back again because we have a lot of material that we need to cover. There's not enough time for us, but we'd like to conclude this episode with this question.
I'm taking a wait and see approach. As I said, I think it's the first thing that has been added to the language in the last 5 years that seems like it might actually change how people use the language. But the way that it's been sort of rolled out and a lot of the other sort of stuff around it is a little bit, it follows a familiar pattern, but is still like very frustrating because, the errors that you get out of spec are not good. And whenever this is brought up, someone from Cognitect will quite rightly point out, well, you could write a function that would go and roll that up and give you a better message. And they're not wrong, but to push such a crucial aspect of the UX of this new feature onto the community is baffling to me. I cannot understand why they would go and just leave that as a like exercise for the reader. And, I say that's baffling, but it's also very much in keeping with how they've sort of talked about these things, which is you have these features which are, powerful, but like they're kind of this core, and then they leave the sort of the remainder of the connective tissue to the outside world as something that people can kind of choose, and that gives the freedom of choice, right? But I think that like that's sort of a false freedom in many respects. I think that like Clojure in general would be much stronger if Cognitect had a blessed set of libraries for solving certain problems, because that would encourage people to go and collaborate on improving the tools themselves and the documentation around them and all that other sort of stuff. But like instead what you get is stuff like tools depths, which is like, oh, well, we have two, fairly popular build tools, but we're going to go and build another one, which is like different and, more minimal and like, kind of tickles our aesthetic sensibilities better. And I understand why they're doing it. I also understand that the fact that it's, being done by Cognitect doesn't mean that like, it comes full formed out of, Rich's head or something like that. But, I talked about this at the conj in an unsession, because one of the things that I kind of talked about in my talk was that I think that like Clojure has a broad but shallow pool of tools, like a broad but shallow ecosystem. And I think that in some way comes out of the kind of people who like Lisp languages, right? This is a curse of the Lisp. And so like to some degree, we're just self-selecting people who like can't help but go and build a like, 12th iteration of a problem which is already solved because we like how ours smells, right? But it's also, I think, something that comes from the top in some respect, in as much as no one is willing to kind of just come in and say, like, if you don't have a really good reason to do this differently, just do it this way. And those defaults matter. They are something that absolutely would help the community grow, because it would allow people who are coming in to accomplish something, right? Not just kind of go and sort of float in the void with all the little orbs around them, wondering like what it is that they're supposed to do with all of them. Like they actually would allow them to get somewhere. And I think that the mean time to accomplishing something substantive in a language is an enormous predictor of whether or not people stick around. And I was fortunate in that my completely bizarre criteria for selecting a language did actually get me somewhere quickly, right? And so I actually sort of built on that initial success. And I think that we're not talking about, outside of maybe the ClojureScript ecosystem, where I think that there's a stronger story for some of this stuff, but I'm not a front-end developer, so this is sort of all secondhand. Like there's not a conversation of, if we want people to feel great, if they want to feel powerful using Clojure, what is the like 10 starter projects that they can kind of work on that will make them feel really awesome, right? What is the 15-minute blog, which was a total lie in many ways, but was a brilliant bit of marketing by DHH, right? The 15-minute blog was exactly what people wanted. They wanted to go and take something that seemed hard and complex and time-consuming, and made them feel like they could basically be a superhero. And so the question was originally about spec, but like I think that spec.
I mean, it's of course. I mean, it's not just. I think you're touching based on spec how it relates to the other parts of the ecosystem.
But also you're making a point which is kind of crazy, really. That the number one complaint from every single Clojure survey is error messages. We always this is from Clojure programmers that have they've taken the pill. We're in there, we're doing it, we're already we're already converted, and we still don't like the error messages. And it's the one thing which is it's a big stick to beat Clojure with. If you go, we go to meetups and stuff like that. It's so annoying when the stack traces come up, or like you say, you get a spec error, and it's just a mile of text. And
I mean it's good scaffolding for better messages.
They are correct that there's a function here, you can transform it, blah 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 blah. Well, just do that then. It doesn't have to be perfect, but do something which is just nicer. Put a bit of effort into it.
And I think that there's also something that I suspect here. So, back when schema first came out,
Yeah.
I was also working on something that was sort of similar in that vein because, data shape validation was important, clearly. The first startup that I worked at, Runa, had enormous issues because it was just going and using printed closure data structures in a database, and there was no validation or anything. It was a goddamn nightmare.
Yeah.
And so there's clearly a need for this. But the thing that I got stuck on was, how do you give good error messages? And one of the problems was, if you go and just put some sort of bare predicate in there, which inevitably you have to, right? There's no way that you can go and you can avoid that. How does that roll back up, and how does that actually get explained as anything other than, here's a printed version of a closure function that failed for some reason, right?
Yeah.
And I think that the conclusion I came to, though I never really quite figured out exactly what that would look like, is that you had to go, and when you specified a predicate, you also had to specify some sort of generator for an error message, some sort of explanation of what this failing looks like, such that these sort of things are in lockstep, because just having the validation doesn't really give us enough information, right? Unless you were actually able to pick apart the function and somehow infer what it was checking. And there's some stuff you could do there, but I think that at the end of the day, you just need to go and force the person who's doing the validation to also explain it programmatically.
Yep.
And the problem with spec is that it doesn't do that, right? It has these really nice combinators for building validators, and those combinators are not giving people the ability to go and describe in plain English or just in any sort of natural language, what is it that you are trying to validate here. And since spec hasn't built that in, I suspect that the error messages will always be a little bit opaque unless you're sticking to the blessed set of validators that it can go and come up with some sort of explanation for. And that's not great.
Yeah.
And that's sort of why, I buy that this can create better error messages. I buy that, it's nice to have some sort of explanation where it's not just the prologue, no, period, at the end of the sort of thing, right? So we can aspire to something better than that.
Yeah.
But the problem here is that I think that it's a clever technical solution to a fundamentally human problem. And I think that describes a lot of what the Clojure core language has to offer. And in some cases, those technical solutions are valid, kind of ways of dealing with the human problem, immutability is a great example of that. Yeah. But I don't think that that's a hammer that you can just kind of swing around and, always fix the problem with. And, one of the things I alluded to at the conj was that, it's something where, the community could step up here, right? Because it's clear that Cognitect is waiting for the community to step up. And so, if we want to have a blessed set of stuff, maybe people just need to get together and do this. And I know that there is a Clojure Together, I think, if I'm remembering this, thing, which I think is an excellent step in that direction. And, I've been sort of talking a big game about this because it's clear that it needs to happen. I also don't know that I want to be the one pushing it forward because I've kind of got enough on my plate. So I keep on kind of talking about it and hoping that someone else will do it, which makes me really no better than Cognitect. But it's something which I think that if we were to talk about what is holding Clojure back, and I think that it's clear that, even if the community is growing, it's not growing at quite the same rate. It's no longer, the prettiest language at the bar. People are not just going and picking up Clojure because Paul Graham told them to. That sort of moment is past. Yeah. And Clojure benefited a lot from being at the right place at the right time, and it's no longer there. It's actually being judged more on its merits than on its potential. And I think that people are still assuming that everyone who's coming to the language is willing to put up with a lot of crap, basically. And that's not true. Or at least not as true as it has to be for the community to still grow in spite of this. And so I don't know what the solution looks like, but I do think that I know a lot of people who got very frustrated with Cognitect because they were waiting for Cognitect to come in and come down from the mountain with the solution on the stone tablets, and it's clear now that that's not going to happen. at least not in a sort of like, near-term time frame. And so it falls to the community. If we want this to happen, we have to do it. And that's fine. And I think that that's a reasonable thing. I think it's frustrating that Cognitect has, certainly intimated this, but never said it out loud.
Yeah.
And I would like to, I think, see more community stewardship, like people actually just going and saying like the time for waiting is over. Like we have to just go and kind of do this. And, frankly, whoever is willing to come up to the table and just say, this is what the community should use, like, that's fine. Right. Like, I think that the one real example of this in the community has been Ring.
Yeah.
And, I think that Mark McGranahan made a series of good choices. I think that James Reeves has, sort of carried that torch forward very ably.
Yeah.
And no one questions that, right? There's no, official kind of, support of that. It's just what the community has done. And the fact that that is the one standout example should be seen as a problem, right? There should be a lot more of that in a much wider variety of cases, as opposed to, 13 different solutions to what is fundamentally an unimportant problem.
But it is changing now, right? I mean, I think it is as you said. I mean, Clojure is not like the most beautiful language that you're going to jump into and then think that potentially it's going to be an amazing language. So now things have changed. I think hopefully more and more people will get into this and then see the warts and try to fix them as quickly as possible.
I hope
think
so.
And
I think that if there is a clear place that will go and welcome them and tell them what they can work on, and not go and close all the GitHub pull requests by saying please sign the CA, we don't take documentation changes, like please fill out a Jira ticket.
Exactly.
Like something which actually goes and says we value your work, we are not going to go and set up a bunch of hurdles for you to go through, is going to be good, right? Because the people who there's a reason that Clojure moves slowly, because a lot of the stuff in Clojure is load bearing and you don't want to change it quickly or without a lot of careful thought. But there's a lot of other aspects of the ecosystem that don't share that property, and we should have a different process. And I think it has to be a community driven one to go and adopt changes. So I don't know, like we've talked forever, so we should probably just cut all this. But
but this comes up in practically every episode. So
to leave on a slightly more optimistic note, though, is I take your point about the popularity, but although for me, I still think I look at Clojure and I still think from an expressive point of view, it is still quite a beautiful language, and I don't see a better language out there actually. I look around and I look at Elm and I look at Rust, and I don't know. It seems like, even maybe Elixir is something which people are maybe looking at, but it still doesn't seem quite as beautiful as the Lisps to me. So,
I mean, I agree. I mean, I wouldn't be here. I wouldn't be writing a book. Like, I mean, I'm being negative. Like, I'm mad because I care.
Right. Yeah.
Right.
Exactly. Yeah.
And I came into Clojure very early, and it did not seem clear to me like what was going to be the kind of ceiling here. Like, there is a ceiling. The parentheses mean that there is a ceiling to the adoption that we're going to see. I think that that's just something that is like a given, but I think that it doesn't have to be where it is right now, and it doesn't have to be where it is like at this current sort of trajectory of growth. And so, the people who are here and who are passionate are they have to be sort of the ones that push us forward, right? Sort of make it succeed in spite of itself.
Yeah.
And I think that that's what it is. And so, I certainly don't mean to go and say like, once I'm done with the book, like I'm out. But at the same time, it's something where, this has been the one language that I've really, fell in love with and have been with since, it was quite young, and have sort of seen how the community has changed and how the expectations of the community have changed and everything like this. And I think that all I'm saying is that there's room for improvement and for clear lines of communications and clearer articulations of who expects what from whom.
Yeah.
And I think that that's just something which, I feel very viscerally that this is sort of something that needs to kind of get resolved. And I'm happy to see that there is progress in this direction, but, we could do with 10 times more.
Yeah. So on that bombshell,
things can only get better. Bombshell.
Exactly. We'll try to conclude the episode. Obviously, I mean, thanks a lot, Zach, for your time and showing up on the podcast and being our first guest for the live streaming. There are at least 21 people watching this, and thank you for watching the video. I'm not sure how this is exactly going right now because I'm not watching the video myself. But please give us your feedback. And a couple of things that we want to cover is that there is a Dutch Closure Day that we are organizing in Amsterdam, March 21st, April 21st, sorry. So the call for proposals is open. So please go and check that out. And if you want to talk about anything, go ahead. And we have amazing sponsors all the way from Switzerland and Finland and everywhere. We've been tweeting about it a lot, and we'll be there. And I think Ray will be there as well. And we'll also show up at Closure D in Berlin to annoy you guys there with our jokes and our other random stuff. Something about Onyx. We'll see. And that's it from us for this week, I think, and our first ever episode on live thing. So if this works out, I think we'll try to do this more. And Zach, we would love to have you back again because we have so many other topics to cover.
Sure, yeah. I mean, let's just say, like, once I have, some sort of little demo to show here, I'm happy to talk more about that and kind of all that stuff. And of course, once the book is actually done and once, the draft has been out there and people have been able to read it, I'd love to hear your thoughts. I'd love to, if there's any sort of, set of reader questions, I can go and just kind of, talk at length about all this stuff. So in any case, thanks for having me on here and, have a great day, you guys.
Yeah,
fantastic.
Thank you.
Thanks, Zach. Before we go, just quickly say thanks to Pizzeri, who does the music, and to Lubov, who does the graphic design for us. I think she's actually doing some awesome stuff for other people in the closure community now as well, which is good to see. So thanks to all you guys. Thanks also to Wouter for doing the sound, and hopefully he'll be able to clean up the mess that we've made on the YouTubes today. Thanks also to the good folks sponsoring us via Patreon. We're now in double figures, and it's really a great and humbling feeling to know that some of you are able to contribute so that we can keep our personal costs down, and also it keeps us motivated to keep taking Defen forward. We really love the idea that the community is coming together for closure. So just to finish off, thanking you again, Zach. Really appreciate the time that you've spared for us. Honestly, been a very interesting discussion, very open. As we expected, very straight-faced, straight-eyed, very open, very clear. So thank you very much for that. And again, thank you very much for all of the contributions and the software and the books that you've put out there and the talks. So you're a pillar of the community. Really appreciate it. Thanks very much.
Cool. Well, like I said, I mean, I'm happy to be here, and I'm certainly happy to see this stuff used, because the only way that I've ever been able to learn is to put stuff out in front of people, and out of sheer terror that I'm gonna look like a ignorant jerk, like work really hard to kind of make it make sense. So this is a little bit more off the cuff than I'm used to, but it was a lot of fun. So thank you.
Awesome. Cheers.
Thank you.
He's actually gone.